screen. So can I get a quick confirmation, guys, whether however I am trying to explain, that is whatever whiteboard I am using, do you guys are you guys comfortable with however I am trying to explain? Are you getting my points clear? Yes, okay. Thank you for the confirmation, guys. So we can continue in the same way, right? We'll continue in the same way and we'll go with it. Okay. Let me just open my Jamboard. This is IIDT internship. So till now, guys, if you want to give I want to just give a recap for you guys. Till now, whatever I have discussed. So first one is first day we discussed something about what is information security, and we discussed some case studies on eBay and Google Play Store. Then we saw how enterprises are being secured CIA triad by using CIA triad, and what are the threats for the organization, and then what are the phases of hacking we saw, and then we started our networking part. TCP and UDP, how basically TCP and UDP work on the transportation layer, and on which OSI, in OSI model, which layer they basically work, and what is basically that called the heart of OSI model, that is transport layer. So after that, we learned something about three-way handshake, about the flags used in networking part, and then I basically gave you a material that is for the assignment. I gave you your first assignment to install and get your Kali Linux and VirtualBox installed, so that whatever classes we are going to see in the future, whatever you're trying to learn, that will be easier for you guys to practice. Okay, guys, today we'll basically start our class from network topologies. From network topologies. So guys, what are these network topologies and how exactly they work? How many types of network topologies are there? So I'll just try to explain you guys. Okay, first of all, what is basically a network topology? So guys, whenever you go for a networking part, in any computer network, so there are basically different ways in which different components are connected. Either it is a server, either it is a computer, either it is any kind of router. So a lot of devices are connected in a single computer network. Okay, so whenever these devices are connected, guys, you basically have some kind of topologies for this. So whenever these components are connected to one another, so there is basically a network topology, which is a way that is completely defining the structure and how these components are connected. So there are different ways. So let me just type here types of network topologies. Types of network topologies, and we'll try to cover under this types. So I guess everyone know. First one is point-to-point topology. Second one is going to be mesh topology. Third one is star topology. Bus topology. And ring topology. So these are basically different topologies, guys. So whenever you go for these topologies are majorly used in networking part. So whenever you go for these topologies, and there are more two topologies, that is hybrid topology and tree topology. So whenever you go for tree topology, and another one is hybrid. Hybrid basically uses two different topologies. So that is why I guess it is called hybrid topology. Okay, so these are basically different topologies, guys. Point-to-point mesh topology and star topology, bus, ring, tree, hybrid. So basically in computer networks, I hope everyone basically had completed this in your computer networks. Those who are in second years or third years, but still we will just try to go through them. I'll just try to brief you guys how they exactly work and what is the basic understanding we should have whenever we are covering these topics. So guys, whenever you go for point-to-point topology, so this is basically like, let me just show you here. You basically have one transmit. So this is basically one. And here you have another receiver. So this is basically the center, guys. This is basically the receiver. So here exactly what will happen is, let's say this person is going to be A. This is basically A, and this is basically B. So whenever you go for this A, B, so this particular sender will send the network and this particular receiver will receive it. And again, this will transmit the data and this will receive the data. So here what will happen is there is no person in between. It is basically going to be the direct communication between A and B. So this is called as point-to-point topology. So if you go for technically, how we will try to tell it is, so whenever you go for point-to-point topology, so it works on the functionality where sender and receiver are there, and it is the simplest communication between two nodes. So whenever I tell simplest communication between two nodes is because whenever there is one person is sender and another one is receiver, so here in between there is no mediator, right? So what will happen is whenever A sends the data and B receives the data and B sends the data and A receives the data, so the network bandwidth will be very high. Network bandwidth will be very high and the connection will be very strong. So that is why point-to-point topology is going to be the one of the highest preferred topology. So this is one, guys, point-to-point topology. Let me just copy this and paste it here. This is point-to-point topology. Now, whenever you go for the definition, let me just keep it simple here. Works on the functionality, works on the functionality of the sender and receiver. There are basically two people, right? Sender and a receiver. Also, it is going to be the simplest communication between two nodes. It provides high bandwidth. So these are the key points, guys. Whenever you go for point-to-point topology, so these are basically going to be the key points you need to concentrate on in point-to-point topology. Okay, let's move for the next one, which is our mesh topology. So under mesh topology, guys, so what will happen is, so each and every device, so in mesh topology, like every device is connected to another device. So how exactly it will work? Let me just show you. So here I have different devices. So let's say this is device one. This is again. So let's say that is device one, device two, device three, device four, and device 5. So we basically have 5 different devices. So how exactly these 5 different devices are connected? These are exactly connected to each other, guys. So how they are connected is directly whenever you go for point-to-point topology here sender and receiver basically have the communication directly. So here what will happen is here also it is the same scenario, but something is different. Let me show you. This particular computer is connected to this one. Again, it is connected to this one, and again it is connected to this one, and also it is connected to this one. So each and yeah, exactly, not like hub. So hub basically you will have something in between. Yeah, guys, I changed my network. I changed my network. So whenever you go for mesh topology, exactly what will happen is one particular computer, whenever you go for this one particular computer, it is connected to all the computers which are present in the network. Whenever you go for this particular computer, it is connected to this network. Sorry, this particular computer, again this computer, again this computer, again this computer. And again, if you go for this computer, again one, two, 3, and again 4. So like that, exactly what will happen is, so each and every computer, whatever is there in this particular topology, they are connected to all the devices. So one device, if there are 5 devices, one device is connected to 4 devices. Again, this device is connected to these devices. So like that, there is basically a mesh formed in this particular mesh topology. So whenever you go for the definition, here, every device is connected to another device via a particular channel. So this is exactly how it is going to work. Now let's move forward. So next we have a star topology. So guys, whenever you go for star topology, in star topology, you have something called as hub. So in between, you will have a hub here. So let me just write here, you will have a hub. So till now, what exactly happened is, so here you don't have any kind of hub switch router in between. So here you will have something called as hub. So here you have one device, here you have another device, and here you have another device. So whenever there is a communication between these particular computers, what will exactly happen is this computer will send the request to hub, and hub is going to forward the request to another particular computer. So exactly this is how it is going to communicate. So whenever you go for star topology, guys, so these all 4 systems, basically what they will do is, so all the devices are connected to a single hub through cables, and this hub is basically going to work as a central node. So whenever I tell something about central node is, all the nodes are connected to this particular hub, and whatever request is coming from one computer or one system, he is basically forwarding to another system. If there is a communication between these two, let's say there is a communication between A and there is a communication between B. So exactly what will happen is A will send a request to B, and B will forward, hub will forward the request to B. So like that, hub is going to be the mediator in between. So let me just write here the definition for you guys. So all the devices are connected to a single hub through cables. Not through cables, through a single one cable, guys. And again, hub works as central node. So this is going to be the definition. Hub basically works as a central node. So this is a definition for star topology, guys. So whenever you go for star topology, so here you will have one common thing is basically going to be hub. Now, whenever I tell something about hub, so when you have now we have routers, right? So now no one is going to use hubs, but whenever you go for past 10 years back, 20 years back, we have hubs. So hubs, how actually they work is whenever you got Ethernet cables or whenever you got some kind of hardware cables for the connection, you are going to keep that particular cable to hub, and from hub all the devices are basically going to get connected. So now basically we have something like local area network. We are using Wi-Fi's and all. But at that time, whenever you go for local area network, you want to make a communication between local area systems and computers, then you need to basically install this hub device and all the particular systems, whatever systems are there. So from that particular system A, you need to connect a cable to hub. From B, you need to connect a cable to hub. So like that, exactly, you need to connect all the cables to hub. Then you will basically form a particular network, and then you can make a communication, build a communication between all the systems present in the local area network. So that is how actually star topology and hub works. Let's move forward. So Anil, like a network server. So server basically forwards the request, but server is going to have some different mechanisms. So hub is basically the one of the basic device which is connected through wires, and it forwards the requests. Hub is completely basic. Server is a little bit advanced to consider server. Now next we got something like bus topology, guys. Bus topology. So can anyone tell me what is bus topology exactly? Do anyone have any idea how bus topology works? So just tell me, guys, bus topology is recommended for the communication or not? Just tell me this thing. Like, is it good or not? No. Why no? Can anyone tell me the reason no? What are the disadvantages? Linear having number of points. It is non-robust topology. Yeah, definitely it is a non-robust topology. So the bigger disadvantage is, guys, because what will happen is in bus. So whenever you're trying to, it will connect many networks at the time. So okay, let me just tell you. So whenever you go for bus topology, it is basically a network type in which every computer and network device are connected to a single cable. So it works in a bidirectional mode and it is multi-point connection. So not like some other topologies. So it is non-robust. The remaining topologies are completely robust. This is a non-robust topology. And what will happen is, because if one cable fails, the whole complete topology crashes. So that is one of the biggest disadvantage of the bus topology. So let me just tell you how exactly it works. So here you have node 1, here you have node 2, here you have node 3, and here you have node 4. So basically we got 4 different nodes, and to this particular 4 different nodes, we got something called as, here we got something called as terminator, and this is basically the part where your complete bus is going to start. This is the part where your bus is going to start. Now guys, exactly what will happen is these all are connected through single cable. So one cable comes here and passes through this, and again it basically continues, and again this connection is made, and again it continues, and again this connection is made, and again it continues till the terminator. So this is basically called as terminator. This is called as terminator. And again, this green line is basically the backbone. So this particular cable name is going to be coaxial cables, coaxial cable. So whenever you go for coaxial cable, guys, so this particular one cable is connecting to all the devices, and if this one particular backbone fails, the whole network will be, the whole topology will basically crash, and there will be no communication between any of the systems. That is why bus topology is not recommended in many cases, and that is the reason why it is called as completely like non-robust network. And the speed whatever the network is going to it supports is basically going to be only 10 Mbps. So 10 Mbps for this kind of topology is going to be really slow, and till the time whenever I want to connect to the last system, the time is going to be really high. So that are basically the biggest disadvantages of this bus topology. So let me just give you the definition exactly how it works. So it is a type in which, okay, it is a network type in which every computer and network device is connected to a single cable that is going to be coaxial cable. So this is exactly the definition. Now, whenever I tell something about the disadvantages, it is important for the disadvantages in this topology. There are a lot of disadvantages. So whenever I tell about disadvantages, first one is going to be, so a non-robust, and second one is going to be cost of the coaxial cable is high, guys. Higher cost. And the last one is if cable that is backbone of the bus topology fails, the topology is going to crash. So this is how bus topology is going to work, guys. Clear, guys, everyone? Any doubts till here? Give me a quick confirmation. Any doubts, guys? Clear. Okay. Let's move forward. Next, we have something called as ring topology. So whenever it comes to ring topology, guys, it is similar like bus topology only. It also has few disadvantages. So let me just show you ring topology. So whenever you go to ring topology, guys, here you will have exactly, this is going to be station 1, and this is going to be 2, this is going to be 3, and this is going to be 4. Now, just a second. You have something else here. Here you will have 1, Yeah, here you will have 2, here you will have 3, and here you will have 4. So here what will happen, guys, exactly is whenever you go for ring topology, the whole devices or the whole systems are connected in a whole ring. So exactly how the communication is built is, so this is basically connected to one station, this is connected to the second one, this is connected to the third one, and this is connected to the fourth one. Now here you will have the ring. This is basically how ring is basically formed. So this is exactly the architecture, how it is going to work. So now here you will have, this is 1, this is going to be 2, and this is going to be 3, and this is going to be 4. So why I am basically numbering this is because, so in this particular ring, so you should have one direction, guys. Either it is anti-clockwise or either it is anti-clockwise. Which way it is going to send the connection, that you need to know. So that is the reason why. So here 1, 2, 3, 4 defines that the connection is going to go in a this direction. So whatever we are trying to share, it basically works in a unidirectional connection. This is basically called as unidirectional connection. So in a ring topology, guys, it is basically forming a ring of devices with exactly 2 neighboring devices. So here this device neighbor is 4, one device neighbor is 3. So there are basically 4 different or 6 different, all are basically going to be even number of devices. The number of devices in a ring, whatever are there, either they can go for large number of nodes. So because if someone wants to send some data to the last node, let's say one wants to send the data to 4, okay. So whenever the data is basically being sent to the last node in the ring topology, so there are basically 100 nodes, then the data will have to pass through whole 99 nodes. So here in our case, we got only 4. So here one is trying to send the data, then it should pass 2, it should pass 3, and then it should go for the 4. So here what will happen is data will have to pass through all the nodes, and it is basically passed like that to prevent the data loss. So to prevent this particular data to basically go from 1, 2, 3, 4 till it travels the whole particular part, we got something called as repeaters, guys. Repeaters are used in these networks. So repeaters are nothing but what they exactly do is, so whenever one is trying to send the data, the data is basically going to pass 2, and then it is going to pass 3, and then it is going to receive on the fourth system, that is basically using the fourth node. So here in between what we are using is, we are using something called as repeaters. We are using something called as repeaters. So what exactly these repeaters do is, they prevent the data loss because the distance is more in between two systems. So the data loss is basically decreased and the data is basically transferred successfully. So data flows is only in only one direction, that is unidirectional, and also it can become bidirectional. So that is up to us, guys. So let me just write the definition. Just a second. Yeah. Ring topology. In ring topology, it forms a ring connecting with 2 neighboring devices. So minimum devices should be connected is 2, that should be in a neighboring directions, guys. So in this particular topology, ring topology, you have either 2, either 4, 8, 10, 12, 16, like even numbers. Okay, with 2 neighboring devices. And here to basically mention the important point, here we got something called as repeaters. So what are repeaters, guys? So these are basically repeaters. So whatever you're seeing here, so this is the station, right? We can basically make this, we can directly send the connection from 1 to 2, 2 to 3, 3 to 4, or 4 to 5. We basically don't need any kind of any kind of repeaters, that is basically these devices in between. So the reason why these devices are there is to prevent the data loss. So this is basically called as repeaters. So they prevent the data loss. So the data redundancy is basically maintained by using these repeaters. Okay. Repeaters are used to prevent data loss. So that is the thing. Why data loss will be done is because of the distance. That is the only reason. So this is how it is going to work, guys, the ring topology. So here also, guys, whenever you go for disadvantages, here also you got something called as whenever this particular single node fails, so it can cause the whole entire network to fail. So the whole network can crash. So here also, whenever you go for bus, so if this particular single node, the central node, backbone of the bus topology, that is basically using the coaxial cable, if this particularly fails, then the whole complete topology is going to crash. Here also, if one particular node, here basically we have one node, two, three, four different nodes are there. If one particular node fails, then automatically this particular repeater will not receive any kind of data, then it is going to stop here. So the communication is going to stop because all the particular nodes are interlinked. All the devices are interlinked. So if one particular connection goes, so all the communication will be stopped. Okay, let's move forward. We have tree topology. Tree and hybrid topology are left. Tree topology. So guys, whenever you go for a tree topology, here we have central hub. Here we have central hub, command C, command V, and again we have two, and again we have okay, it's systems. Okay, let me just make this. This is a central hub. This is one particular system. This is another system. This is the secondary hub here. And this is going to be the secondary hub again. So here three hubs are being used. Here you have system 1, system 2, and again system 3 connected. This is going to be the secondary hub. And here again you have secondary hub. And again here you have one system, two system, and three systems connected. So here guys, exactly how this is going to work is, this is going to be the second central hub. From central hub, system 1 is connected and system 2 is connected. And again, this central hub is basically extended by using secondary hubs. This particular secondary hub, and again you have another secondary hub. To this particular secondary hubs, you have another system, three systems connected here, and again three systems connected here. So this is basically called as secondary hub. Secondary hub. And this is basically, sorry, this is central hub, right? This is secondary hub. This is also secondary hub. Just a moment, guys. Secondary hub, secondary hub. And again, you have the central hub. So whenever you look at this architecture, guys, here itself you can understand by using the central hub and secondary hubs. So the complete tree is basically formed and the connection is being established. So here you have system 1, system 2. Here you have system 3, 4, 5, and here you have 6, 7, and 8. So whenever you go for the definition, so in this particular tree topology, there are basically variations of star topologies. So here you have something called as hierarchical flow of the data from this central hub to secondary hub to another number of systems. You have the flow of data is basically being hierarchical. Flow of data is basically being hierarchical. And here, whenever you go for the whole figure, guys, secondary hubs are connected to some central hub, which contains the repeater. Again, you got something called as repeater. So here the data is being flowed from top to bottom. That is from the top central hub, and again down you have secondary hubs. It is basically flowing in this way. And again, in the same direction, you have the systems connected in between. So the data flows from the top to bottom, and whenever you go for the secondary hub, it takes that information from the central hub, and then it basically transfers it to the different systems. So that is how tree topology exactly works. So in tree topology, there are a lot of advantages, guys, because it allows more number of devices to get connected. There is no limitation for the devices. You can basically define different hubs, and you can take it as a tree in a flow directional way. So here, if I want to connect another particular number of devices, again, I will call for another hub and I will extend it to the connection to the another devices. Like that, you can go for n number of different connections can be built for the n number of connections are being built to basically to basically make this flow of the network in different devices. So call for the hub and again connect it to the devices, again go for third hub, fourth hub, fifth hub, doesn't matter. So here you got only single central hub, which is basically using as a main person who is basically important, which is basically important for the whole transmission of the network. So that is how it is going to work, guys. Okay, let's discuss further points. So we got something in the last one. Let me just write the definition here. So various secondary hubs are connected to central hub, which contains the repeater. So this contains the, okay, connected to the central hub, which contains the repeater, and the flow is going to be here. The data flows from top to bottom. So here, guys, whenever you go for this 1 and 2, these basically 1 and 2 work as a repeaters. This basically 1 and 2 works as a repeaters. And whenever here it is mentioned that connected to central hub, which contains the repeater. So central hub basically contains two repeaters. So these basically are repeaters, and from that only basically the data is being transferred from secondary hub. Again, another secondary hub can be called. Again, different systems can be connected. So that is how it is going to work. So here, what is the backbone, guys? Here, the backbone of this whole topology is going to be this central hub. If this particular central hub fails, the whole topology is going to get crashed. So here, central hub is going to be the backbone of the complete tree topology. So advantages are again allows more devices to get attached to the single central hub. So how many secondary hubs you can call, it's up to you. You can basically connect n number of devices. Whenever you go for drawbacks or whenever you go for disadvantages, central hub can fail anytime, then the whole entire topology can crash. Okay, let's move forward. The last one you have hybrid. What is the meaning of topology here? Guys, so here I mentioned, I guess, right? What is the meaning of topology? Okay, let me just write here the meaning of topology also. What exactly the topology means. So guys, whenever you go for topologies, so whenever there is a basically a communication between one device and another device, okay, there are n number of different components in one particular network. So to connect those components, you basically need a common thing. So one particular component are connected to another. So for that, you basically need a network topology. So it is the way which basically defines the structure and how the components are connected, and also how communication is basically built between each and other devices. So let me just write here. So topology, it is a way that defines the structure of communication between the devices. Sorry, between the components connected to each other. So this is exactly what is topology, guys. So try to remember this definition, guys. Try to remember the definition. Okay, let's move forward. Yeah. So this is basically how tree topology exactly works, guys. So just a moment, guys. Yeah, guys, sorry for the interruption. So last one here we have something called as hybrid topology. So here, guys, hybrid topology is nothing but you can basically tell it is like you can tell ring topology, and it is going to be the another topology, which is star topology. So whenever you go for these two topologies, they are basically interconnected by one particular station in between for the communication. So this particular hybrid topology is used to avoid a number of, you can tell, if there is some kind of you can tell like, so whenever you take an example of bus topology, you have some failure rates, right? So if one particular backbone fails, the whole network gets failed, something like that. So here in this particular hybrid topology, so how it is used is the technology is used in a combination of various types of topologies. So hybrid topology, we can use nodes are free to take any form. First thing, any node can take any form. So which means we basically use ring and star topology, or can be any combination of various topologies. You can use two topologies, either three topologies, either four topologies, that is up to you. So here you are basically defining one topology and again another topology, and you are basically making a connection between them by giving a station in between. So like that, you can use multiple topologies, which will make the whole connection completely flexible, and it is going to help you to add n number of devices. That is, you can add more number of devices as compared to normal topologies. So if you basically eliminate this tree topology and look for all the topologies, uh, whatever we discussed in those topologies, somewhere there is basically a limitation. So if either there is a limitation or there is a lot of time which is taking to communicate between one particular system to another particular system. So like that, if you go for a hybrid topology, the whole goal is whenever there is a failure. So if one topology fails, another topology can work and another topology can work like that. So that is why this particular hybrid topology uses the combination of 2 to 3 topologies. So let me just write here. So this topology is the combination of all the various types of topologies and whenever you go for a few of the advantages, here we have topology is very flexible. And second point is size of network. Network can easily be expanded by adding new devices to it. So this is how actually a hybrid topology works, guys. So okay, now I guess we are done with the topologies part. Let's move further. So here in the next upcoming topics we have, guys, we have something called as firewalls. First thing, we got something called as firewalls. And again, we have to discuss how basically IP addresses work, how are they being designed, how basically IP address is assigned whenever you connect to any of the network. And in firewall types, you got something called as intrusion detection and intrusion prevention system. So we'll just try to complete these 4 topics in the next 1 hour. Let's move forward. So now guys, we got something called as firewall. Okay. So what is basically firewall? Can anyone explain me what is firewall and how it works? So okay, we'll do one thing. We'll keep the firewall for the next topic. We'll try to discuss IP addresses first. Can anyone tell me what is IP address and how IP addresses are allocated? Guys, can anyone tell me internet protocol? Yeah, I know it is internet protocol, but how basically this internet protocol works and how exactly it is going to allocate on the internet. So either whenever you are trying to connect to trying to connect to a router, so how your router is basically giving you, how is it giving you the address, guys? DHCP. So can anyone tell me what is the full form of DHCP? Guys, can anyone tell me what is the full form of DHCP? Just a moment. Yeah, guys, it is exactly called as dynamic host configuration protocol. Now, let me just tell you how this IP addresses work and how exactly it is going to be. So whenever you go for the IP address, guys, IP address is defined as internet protocol first thing. So whatever device is going to use, whatever device is going to basically connect to internet and whatever they are using. So for that particular device, there should be an address, right? That particular address or that particular name is going to be IP address. So you can basically use this IP address. It defines your identification on the internet. Now, whenever you go for this IP address, now each and every particular device is connected to one particular network. Let's say my device is connected to, here I have, yeah, just a moment. Here, this is basically my device, and this device is going to get connected to a router. So this is basically one router. And now whenever I connect my device to this router, guys, what exactly happen is my IP will be something like 192, 168, something like that. And again, if I go from, this is my home router, okay? This is my home router. And if I basically go to office and I connect it to my office router here again, if I connect to my office router, then my IP address is going to be 172, something like that. Either 172, either you can go for 10.0.2.17, something like that. Now, each and every time, why is my IP address getting changed? So whenever I go for my IP address, whenever I change the connection, either I basically connect to this particular IP address, this particular router, each and every time my IP address will change. Can anyone tell me how my IP address is getting changed? So if you want to know about your IP address, you can go to command prompt. If you are using Windows, you can go to command prompt and type ipconfig. If you are using Linux, then you can go for ifconfig. So both ways are there to get to know about your IP address. So guys, here the reason is DHCP server. Let me just show you the architecture, how exactly it is going to work. Now, what is DHCP server and how exactly it works? So here I have an image of DHCP server, this one. So try to look at this architecture. Try to look at this architecture, guys, and tell me what are you able to understand. So IP connected devices, mobile phones, some kind of ATM machines, CCTV cameras, request access to IP address, DHCP server can set up for the redundancy and clustered among the other network servers, network configuration parameters, default gateway, subnet mask, and DNS server. Now let me tell you how exactly this is going to work and how you can understand this whole process. Now, here guys, please try to concentrate on this part. This is very important. Okay. So these are basically devices which I am using. So one is mobile phone. One is mobile phone. One is mobile phones. Second one is going to be laptops. Third one is going to be my smart TV. Fifth one is going to be my CCTV cameras. And again, if I have something like Alexa or any of the IoT devices which are connected to the router. Now, these all devices are going to access the internet. Am I right, guys? Either mobile phone, either laptop, either CCTV, or it is going to be or it is going to be CCTV, Alexa, or whichever a device. So whenever you go for these particular devices, guys, these device, all devices are basically have one requirement, that is going to be internet. Now these devices, what I will do, I'll basically take these devices and connect them to a router, in my particular home. Now, under this router, whenever I connect them to a router, we basically have something called as DHCP, Now, whenever I tell something about DHCP, what exactly DHCP will do is, in this particular local area network, whenever you go for a DHCP, see, two scenarios are there, guys. If you go for corporate, you have the whole server set up for the DHCP. Whenever you go for home networks, you don't need the whole server. You can basically use router, which can be used like a DHCP. Now, what this exactly router will do is, in this particular communication, whenever this IP mobile phone is trying to connect, now what it will do, it will try to send a packet. That is basically, it will try to send the packet to this particular DHCP server. Now here you have something called as, client, and here again you have something called as server, DHCP server. This is going to be the DHCP server. This is going to be the DHCP server. And this is going to be your client. That is basically going to be your laptop. Exactly telling. This is basically your laptop. Now what will happen is, whenever I basically go to my home network and whenever I try to connect my laptop to my router, what will happen is, this particular laptop is going to send one packet of data to this particular server. One packet of data. There are basically 4 steps to communicate with the DHCP server. So this is basically DHCP server. There are basically 4 different steps to connect to the DHCP. One is DHCP discover. Why I am sending this packet? I am sending this packet to discover the DHCP. Here I have DHCP discover. DHCP discover. Now, what is the second step? Once I basically know that there is a DHCP present, then what I am going to do is, so DHCP is going to send me a offer, guys. DHCP is basically going to send me a offer. Now here what I am doing, I am sending a packet. A discover packet is being sent to the DHCP server from the client, and after the packet receives to the DHCP server, the server replies to the client with a DHCP offer packet containing the IP address. We are going to first we are going to send a packet and request for the IP address. Then we are going to receive one packet, and in that packet, what we are getting? We are going to get an DHCP offer. Here we are basically going to get DHCP offer. Now under this offer, what we are getting is, under this offer, we are getting something called as IP address. IP address. Here we are getting something called as IP address. Now, once you basically get the IP address, after getting the IP address, again, there is basically one particular communication which is going to be, again, you are sending one more packet of data here. Again, one more packet of data is being sent. And now here, the client receives, once the client receives the IP address, then he basically validates the offer and then sends the request packet back to the server to accept the address. Now, if you basically want to accept this IP address, you again need to send one packet. That is DHCP request packet. DHCP request packet. Once you basically send this DHCP request packet, then there is going to be the final packet. Now you have accepted the IP address. That is basically you send this DHCP request. Now after you accept the IP address, then the DHCP is going to send another packet about acknowledgement. So the server sends the acknowledgement packet back to the client to confirm the chosen IP address. So he'll basically tell that, okay, you can keep this IP address, use it. Now, till what time can you use this particular IP address? Till you are connected to this particular network. Till this laptop is basically connected to this particular network, till that time only you can use the network. if you're basically if you're basically not connected and you disconnect from this particular server, then your IP address will be taken back by the DHCP server, and again it will be given to some another device which is trying to build the connection. So like that, each and every time what will exactly happen is acknowledgement. Each and every time exactly what will happen is whenever a new device is getting connected to this particular either router. So let me just write it clearly, guys, here. So router in home device, home network, and DHCP server in corporate network are used for allocation of IP addresses. So here let me just mention this point. So try to remember this, guys. Try to remember this. Router in home network. Router is basically used to allocate the IP addresses. And in corporates where there are 100 to 200 laptops and 200, 300 devices, there you need to set up the DHCP server. So that server is basically set it up because it is going to use some high number of IP addresses are being generated. That is why we need to set up the server. Now, in this case, whenever just try to understand this once again, whenever some another devices come to our network and they try to connect to our either router or either DHCP server, so what will exactly happen is this particular client is nothing but your laptop or mobile phone. Whenever this particular mobile phone or laptop is trying to connect to the DHCP at the first time, what will exactly happen? First thing, a discover packet is sent to the DHCP server. Once the discover packet is sent from the client to the server, then this server is going to send the IP address. So DHCP discover packet is sent because this particular laptop want to tell that I need a IP address. I am connecting to your network. I need the IP address. So give me the IP address. DHCP will accept the offer and it is going to send the IP. It is going to send some another packet of data. In that packet, you will have the IP address present. Now, once this IP address is received by the client, so if the client want to keep this IP address, he need to again send a request packet telling that I will keep this IP address. So once he basically accepts to keep the IP address, and again server will send a packet of data of the acknowledgement. Okay, you have chosen this IP address and it is finalized. You can keep it. So these all steps are being done. Whenever a device is connected to a router, these all steps will be carried forward and each and every step is basically done, and then only there is a communication between the client and then only he'll be able to access the internet from the router or server. So each and every time, guys, try to remember each and every time whenever you connect to a router or connect to a DHCP server, so each and every time your IP address will change. Now DHCP is going to give you IP address. Once you ask for the IP address, it is giving you the IP address. But till what time it is giving you the IP address? It is giving you the IP address temporarily. So it is giving you an IP address on a leasing time. So it will basically lease you the IP address. The reason why it is leasing you the IP address and not giving you the permanent IP address is because once you disconnect to the network, it will take back the IP address, and again it can basically create a new IP address. By using that IP address, it will give the same IP address to another device. So like this, whichever device is getting disconnected, IP addresses are collected back by the DHCP, and whichever new device is again joining the network, again that particular IP address is given to that particular device. So like that, each and every time it is not important that DHCP should create a new IP address. It is going to give you the IP address temporarily. You can accept it. You can use it till the time you want to use it. And once you are done using it, you give it back to the DHCP. Once you disconnect, it will automatically go to the DHCP and it will allocate the same IP address to another device which has a requirement. So that is how exactly DHCP server works. So let me just write down the steps here for you guys to exactly understand how it works. So we got step 1. Just a moment. Yeah, guys. No, you can't, Anil, sir, but we can change the IP address individually to a system permanently. So there is nothing like IP address can never be permanent to a particular device, because whatever internet you are using, whatever internet you are connected in, so that particular internet will give you the IP address. So if the router has a limitation that only 100 systems should be connected, then you will not get the connection to that particular router. So there is a limitation. So like that, each and every time you are basically trying to connect to a new network. No, we can't. There are static and dynamic IPs. Uday, what are you trying to tell? Can you please elaborate once? Okay, I understood. You are answering to Anil. Okay, understood. No, we can't. There are static and IP. He asked about the change of IP, right? Yes. So guys, sir, what use of DHCP? Array, this is a complete thing, right? DHCP, dynamic host, whatever I'm trying to tell. So DHCP is basically used to allocate you the IP address. So this whole explanation is for DHCP only. Okay, fine. We'll move forward about the steps. So here discover packet is sent from client to server. And then step 2 we got server replies to client with DHCP offer. DHCP offer packet containing the IP address. Then step 3, you got client receives and validates the request. Sorry, validates the offer it is. Validates the offer and sends back the request packet. Server to accept the address. Step 4 we got server sends an acknowledgement packet to the client to confirm chosen IP. So this is exactly, guys, how it is going to work. So you got this many different steps: step 1, step 2, step 3, and step 4. So based upon this particular architecture on the left side, based upon this particular part, whenever you go for the whole number of steps, whatever I told. So in this 4 particular networks, whatever we are trying to send. So here one packet is sent, here again one packet is received, then one packet. So this is step 1, this is step 2, this is step 3, and this is step 4. There are 4 different steps. I hope everyone it is clear. Just try to note down these steps or take a screenshot or something and try to learn it later, how it exactly is going, how exactly it is going to work. Clear, guys? Let's move forward. Okay. Yeah. So here I need to mention one thing clearly. Done. Okay. Okay, let's move forward, guys. IP addresses topic is done. So IP is not a permanent address. It changes dynamically when we connect to a network. Exactly. So whenever you connect to a new network, you will be assigned a new IP address. I hope now everyone understood. Sir, what is the full form of DHCP? Okay, DHCP. So here I guess I don't have place to mention what is DHCP exactly. Yeah, here I can write. So guys, DHCP is nothing but host dynamic host configuration protocol. Dynamic host configuration protocol. Keep it in the same way. I'll keep it here. Then guys, I hope now it is clear. Dynamic host configuration protocol. Here you can just, whenever you're trying to read, it will be clear for you to study how it is going to work exactly. Done. Sir, what are network configuration parameters? Based on this, you will have assignment. Take notes. Okay. Sir, is there any full form for DHCP? Yeah, it is dynamic host configuration protocol. So guys, now I got something. So whenever you go for this number of IP addresses, right? There are in basically a number of IP addresses. So this particular server has basically some kind of limitation. Okay, each and every server has basically limitation. I can send this. I can set this particular server to only assign 2 IP addresses, to only assign 100,000, 10,000, 1 lakh IP addresses. So how basically I am going to limit this IP addresses? Because see, whenever there is a company, any kind of company, right? So whenever this particular company basically has 100 employees, so it is important that this particular company should have 100 employees, and only DHCP, this particular DHCP server should give 100 IP addresses, not 1,000 IP addresses. So if it is ready to give 1,000 IP addresses, whoever will connect, he will basically have the IP address, and he can basically go and connect to this particular what you say, internet connection. So for that, we basically here have something called as subnet. So subnet is a network within a network, guys. So which is basically going to, you can tell it is defining, it is basically dividing the IP address into different classes. So how it is, so what is DHCP? When is it used, sir? See, guys, this whole whatever I explained now, this is all DHCP only. I hope, I guess you are not in the class from that time. That is why you are asking again, what is DHCP? When is it used, sir? So try to concentrate in the class, whatever I'm trying to tell, whatever I'm trying to explain. Please try to, okay, guys. So what I was telling, yeah, subnet. So whenever you go for a subnet, guys, it is basically a network inside a network. How exactly network inside a network, how it is basically works is, so it is like a subdivision of the network. How you're doing subdivision of the network? So if one particular network is there, you are dividing that particular network into different parts. So how is it exactly dividing into different parts is, so whenever you have IP addresses, right? Whenever you have IP addresses, whenever you have lot of hosts and whenever you, so what is exactly happening is, so let me just show you practically how it is done. So here you have one and command C, yeah. Here you have two, here you have three, and here you have four. Now guys, what will exactly happen is here. So whenever you go for this particular part, so these are all nothing but bits, guys. These are all nothing but bits. So now here we have two differences. It means right here, I will show you before subnetting, something before subnetting and something after subnetting. What is exactly subnetting? You will try to understand after subnetting. So here before subnetting, exactly how it will look is, it will look like this. So here before subnetting, each and every IP address, so whenever you go for this particular part has some bits of data. So here before subnetting, these are basically going to be reserved bits. You can basically name them reserved bits. Reserved bits. And again, you have network ID in the second part. And in the last part, you have something called as host ID. Now, while networking, what exactly will happen is this host ID will be basically divided. This host ID will get divided into subnet ID and host ID. Now, I'll exactly tell you why do we need exactly subnet ID and what are subnets exactly used for. So here you have again reserved bits, guys, same thing. Here you have again network ID and here you have host ID and the last one is going to be your subnet ID and host ID. See, exactly this. So this is basically going to be your subnet ID. Subnet ID. So why basically we need subnet ID? Why basically we need to divide the host ID into two parts is because, so here what exactly will happen in subnet? So it is basically a subdivision of IP network. So it is a kind of practice where you are dividing the whole network into two or more networks. That is the basic thing. Now here, whenever you go for computers, whenever you go for the whole network, let's say 100 computers are there. This particular 100 computers need 100 IP addresses. They don't need 1000 IP addresses. So whenever I tell they only need 100 IP addresses, how are you going to define that they need 100 IP addresses only? So here you got something called as subnet chart. Let me just show you how exactly subnet chart works. Subnet chart. So this is also going to be your assignment for today. Just try to concentrate. There is one subnet chart which is really clear. Yes, this one. Yeah. Save image as downloads. Save. Let me show you how exactly it works. So try to look at this, guys. I hope it is visible to everyone, right? Now, here, whenever I basically have here, what do I have? Subnet mask. I have network bits. I have number of hosts per subnet. I have class of subnets. I have class B subnets and class C subnets. Now here exactly what I am going to do is, if I basically use this prefix, that is whenever you go for /8. Oh, only /8. Okay. /8 /10 to /30. So number of host per subnet. If I basically use /30 here, if I basically use /30, exactly what is happening is If I use slash 30, only two particular IP addresses will be generated. If I basically use 29, 6, 28, 14, 27, 30, 26, 62, like this, each and every network we can basically divide. Each and every network we can basically divide. And whenever we want to divide this network, we are going to use this subnet. This is also called as CIDR block. This is also called as CIDR block. So whenever you are trying to basically divide your network, you will basically give a number, that is slash 30, slash 29, slash 28, slash 27. So you got 30 hosts per subnet. If I keep slash 30 and if I give one particular subnet mask, then only 30 users will be able to use the particular IP address, then 60. So from this 255.0.0.0 to 0.0.0.0, you have something called as unlimited IP address. First, it starts from 0.0.0.0, that is unlimited IP addresses. Then again, you have 255.0.0.0, that is 16 lakhs, again 8 lakhs, again 4 lakhs, again 2. Like this, it will be decreasing. So each and every time, whenever you go for corporates, guys, whenever you go for corporate networks, you got something called as subnet mask. So they will basically use this particular subnet mask, and they'll basically keep a subnet mask, and they'll basically give a suffix to the particular number of subnets, IP addresses. So what will exactly happen? You are going to lower the number of IP addresses which are getting generated. So like that, each and every corporate, or whenever you go for each and every network, you have some limitations. For that limitations, you are going to give this. So that is how subnets work. Now this is going to be your be your assignment for the next class. Try to learn all these subnets. If you have any doubts, try to research and try to clear out your doubts on your own. So whatever you have, you should get answers in by next class itself. You should not wait for me to clear it. Okay. Yeah, guys. Just a moment. What is this? Okay, I don't need this, I guess. Yeah, clear, guys. Try to learn how this exactly works. Okay, let's move forward. I guess this is completed. Let me just name it part 1. Okay. So till here, we completed the networking part. Now we are going to enter into the firewalls part. How exactly firewalls work? Can anyone tell me what is the difference between firewall and antivirus, guys? What is the difference between firewall and antivirus? Anyone? Quick, guys, I need quick replies. What is the difference between firewall and antivirus? Antivirus removes the virus. Firewalls is so, guys, whenever you go for firewall or whenever you go for antivirus, so firewall is basically used in some kind of corporate networks, where it is going to remove it is going to restrict the particular IP addresses to access your network. And it can also be used as a host to basically monitor who is using the network and what is happening. And antiviruses are used to remove the malware from your particular, restrict the malware or viruses to get downloaded or injected in your laptops. So antiviruses are used on a laptop basis, and firewalls are basically used on a organizational level, that is corporate level, exactly telling. Okay, let's move forward. Here we have firewalls. Firewalls. Antivirus removes malicious software. Firewall is a barrier which accepts or restricts. Yeah, exactly. All the answers are correct only, guys. There is nothing like some people are giving wrong answers. So everything is correct only. Just I'll try to improvise your answers, whatever you're trying to tell. Just give me one moment. So guys, for your understanding, let me just first tell you how exactly these firewalls work and how they'll basically be in the architecture. So Sudhir, you will get the attendance by the end of the session. Our session ends on 9 o'clock. So exactly at 8:55 or 8:50, once I basically end up explaining everything, then you will get the attendance link. Yeah. Client, you got server, and here in between you got something called as firewall. This is basically going to be your firewall, guys. So this is exactly going to be your firewall. Now, whenever I tell something about firewall, guys, firewalls are basically used whenever you go for the definition. Firewall is going to be a network security device that monitors and controls incoming traffic, outgoing traffic. Whenever I tell not okay, 1 minute, guys. So, guys, here let's say in client server model, this is basically going to be client. This is going to be client, and here you have something called as server. Okay, server. So, okay, just yeah, this is going to be the voice is not clear. Just a moment, guys. Guys, quick confirmation. Now my voice is clear. Clear for Rahul. Okay, okay, okay. Yeah, done, done, done. So guys, here you have client and here you have server. Okay. Here you have client and here you have server. So here in between, I have something called as firewall, guys. Here in between, I got something called as firewall. Now, exactly how this firewall will work is whenever you go for a client, so whenever you go for a normal network, firewall is basically going to be a network device which is going to control the incoming traffic and outgoing traffic from a network. So exactly telling, just a moment, let me just okay, client, server, firewall. So this is not exactly for this. So let me just remove this. And this is basically client server model. And here you got. So let's take an example of our offices, guys. That is basically going to be your corporate network. So in one particular corporate network, whenever you go, so they have something called as, so I guess everyone know what is a network. What is a like a corporate network, how it basically works in corporate network. What will exactly happens is, so you have your laptops are completely locked. You can't browse YouTube, you can't browse social media, you can't browse any kind of websites which you can personally which you can browse on your personal computer. So exactly what will happen is, so in this particular client server model, in this particular client server model, so here you have something called as, so this is basically the whole architecture. Let's say this is basically the whole architecture. And here you have like database, one database connected. So one database is basically connected here. So now whenever you go for firewalls definition, guys, it basically defines that it is a tool which is going to control the incoming and outgoing the outgoing traffic of the particular network. So let's say this is the complete network here. This is a complete network. So in this particular complete network, guys, in this particular complete network, there should be one point, right, where from the whole network is being basically accessed. So here, let's say there is basically one network from where this particular server is being accessed or whatever is being accessed. So now here what will happen is if someone from outside is trying to access your network, if someone from outside is trying to access your network, so exactly, let's say this is the network. This is the whole network here. And here this particular client want to connect to this particular server. So exactly in between the connection, what will exactly happen is there will be basically one firewall present at this entry point. At the entry point, there will be one particular firewall present. And whenever this particular client basically is nothing but in the network point of view, it is basically a simple IP address. This IP address is basically trying to connect to the server. So whenever this particular client is basically trying to build a connection with the server, in between there is a firewall. Now everyone know that firewall is going to control incoming and outgoing traffic. So whenever this particular IP address is verified, then that IP address will request, then this particular IP address is requesting to access the firewall. Then if this particular firewall thinks the IP address is secured and the client is basically the known person who can access the server, then he can exactly then this particular client is allowed inside to build a connection to the server. If this particular IP address is an unknown IP address, then the connection is not builded and firewall is going to block that particular network from getting connected to the server. So the connection is not connected. What are these, sir? We have not got attendance link last session in Telegram group. Can you please share me, sir? We are not got attendance link in the last session. Guys, this is going to be your third session, and in this third session, you got I know that everyone got attendance link. So in the last session, I made sure that you receive the attendance link, guys. So yes, sir, last session. See, guys, how many of you got the attendance link in the last session? Can you confirm in the chat box? Did you get the attendance and feedback link in the last session? Quick confirmation. Got. Yes, sir. Yes, sir. Yes, sir. Guys, last session in the sense, I am not talking about the cancelled session. Before cancelled session, where I gave you an assignment of TCP and IP protocols, TCP and UDP protocols. Yes, right. See, the basically that particular link is being shared each and every day, guys. That is mandatory what we do. So it is not like we forget sometime and we basically do it. And it is not shared in the Telegram group. In the live class, in the chat box itself, you will get the link. So please try to be attentive so you will be able to fill the form. Okay, let's move forward. So guys, see what I'm trying to explain is whenever you go for firewalls, so basically this firewall works on incoming and outgoing traffic, incoming, outgoing traffic. So whenever I tell something about incoming and outgoing traffic, technically this is basically called as inbound and outbound traffic, guys. Inbound and outbound traffic. So inbound is nothing but incoming traffic and outbound is nothing but outgoing traffic. So whenever you go for inbound and outbound traffic, guys, so firewall, what it will basically do is under this particular firewall, we got something, how basically firewall works. So this firewall, one point is it controls, let me slide it clearly. It controls inbound and outbound traffic. The first point is going to be incoming and outgoing traffic. Now, second thing is, how is it going to block the particular IP addresses? So this particular firewall has something called as rules. In under these rules, guys, you can basically disable IP addresses, disable IP addresses from building a connection, building a connection, or using from building a connection or trying to connect to any network. So under these rules, guys, under these rules, you can either disable IP addresses, you can either enable IP addresses. So it is completely on firewall how it is going to act. So in this, we are basically going to build some kind of rules. Now, disabling IP address from building a connection or trying to connect to any network. This is one thing. Now exactly try to concentrate here once. So whenever I speak something about rules, now if this particular firewall, I give this firewall some kind of 100 IP addresses, okay? I give this firewall 100 IP addresses, and except this 100 IP addresses, I basically build a rule. I basically build a rule that the another IP addresses should not be able to connect and should not be able to build a connection in any device. Either it is a server, either it is a database, or any device which is under the network. That time, what this basically firewall is going to do is, if it is a known IP, that is whatever list of IP addresses I gave to this particular firewall, it will try to cross check from those 100 IP addresses. If this particular IP address doesn't exist in this 100 IPs, then it is going to block the access. If it is exactly present in this 100 IPs which I gave in the rule set, then it is going to allow the connection and it is going to allow it to build a connection with the server. So this is how firewall works. So basically, if you have a firewall, the reason why setting up the firewall is to protect it from unknown access, to protect your servers, or to protect the people, or to protect the unknown IP, or protect it from unknown IP addresses to access the database. So whenever you go for, if you have a database here connected to a server, if you basically have a database in the architecture, so if you basically want to protect this database from anyone accessing it, if you want to, if this is basically containing some kind of private data, and this is completely private database, and you want to limit the connection for this database. So you don't want anyone who is present in the network to access this database. That time you are going to give only 4 to 5 IP addresses to this particular firewall. They are also called as rule sets, guys. Whenever you are setting the rules, you got something called as rule sets. So you are going to keep these rule sets. You are going to define these rule sets, define the rules in this firewall. So this firewall is going to, based upon the rules, it is going to either accept and it is going to allow the client to build the connection, or it is going to cancel and it is going to block the IP addresses. It can basically block the IP address. Sir, but IP addresses change dynamically. How can a firewall find the known IP address? See, IP addresses change dynamically. I know that IP addresses can change dynamically, but whenever you go for firewall, guys, in the internal network of the office, whenever you get a either office laptop or something, under that office laptop, that is basically configured in a way that it can basically connect to any of the server. And one more thing, if you basically bring your personal laptop to the office, then it is difficult for you to get the IP address from the DHCP. So here, whenever you go for DHCP, so that particular DHCP, once you basically get the IP address, then automatically each and every time you're going to get the new IP address. You can get the new IP address, but whenever you have the firewall present here, it will, just a moment. That is not BB, that is a database. This is a database, just a moment. So guys, whenever you go for office parameters, so under those parameters, if you are using an office laptop, then you have a different network, different Wi-Fi. And if you are using personal laptops, you can connect to different Wi-Fi. Right? Exactly. Whenever you go for firewalls also, firewalls are basically set up on the office network, which are connected to the servers and databases. And there is one public Wi-Fi which you can use with your mobile phones and anything. Now, whenever you are using these office laptops, the device configuration, the router configuration, the server configuration is done in a way that you automatically get to access the server. Guys, don't try to, what is happening in this chat box from that time? Can anyone send a Telegram group link, time for attendance, form link? I didn't get first session attendance. See, if Hemant, if you didn't get first day attendance, it is not our fault, right? We basically shared the link and there are a lot of people who got attendance. So don't try to tell I didn't get first attendance. No one is here to give you attendance each and every day. This is not school or university where you tell I was present, I didn't come to class, I had this reason and I mark you present. There is nothing like that. Wait till 8:55, wait till 8:59, wait till 9 o'clock till the internship close, till the class closes. Till that time you need to wait. Then only you will get the attendance link. And once you get the attendance link, you fill it and leave the class. Doesn't matter. Till that time, no one is allowed to leave. See, here it is already been shared, right? Blackbucks feedback form. Still, what is the problem? I don't understand. You guys keep on asking the same thing again and again in the class. So the people who are listening, the class, people who really want to learn, they are basically getting the problem. So this chat box is for normal usage, guys. This chat box is not for your conversation. So I'll just change it to directly message to me from tomorrow. That is the best thing which I can do. So directly you can message me, or else you can't even interact with other students. That is the best part I can do. So let me just repeat this once again, and please don't try to make a mess in the chat box right now. Try to concentrate and listen. So whenever you go for firewalls, they are basically devices which try to so firewalls are basically devices which work on a network basis, guys. Whenever you go for network basis, either you can limit the access of the particular devices which are under the network. So by giving the IP addresses, whenever you go for IP addresses, you can limit the number of IP addresses which can try to access the infrastructure of one particular network. So under this particular network, whatever I have here, in this particular network, there is one server and one database. So I don't want anyone from outside to come and connect to my server and database. So what I will do is I will set some rules. So once I basically set some rules, so based upon that rules only, this particular firewall will try to allow this particular clients to come from outside and build the connection. So this is basically how network firewall works. Now there is one more type of firewall, which is host firewall. So there are basically two types of one is basically network, which operates on network. One is which operates on host, and another one is proxy. So there are basically 2 to 3 firewalls. So today, I guess we'll just stop till here. Tomorrow we will go with intrusion. One is packet filtering firewall, stateful inspection firewall, and proxy firewall. We'll just complete this tomorrow, and after this, tomorrow in the next class we'll basically go with intrusion detection systems, intrusion prevention systems, and then we will basically close our networking part and move forward to operating systems. Guys, what is this? Who is posting this 21HU1A0446 roll number in the group? Who asked for the roll number here? We don't need roll number. So I am sharing the feedback link. Once you give the feedback, automatically attendance will be marked. Venkat, I am sharing the feedback link. So try to give this feedback, automatically attendance will be marked. I am doing it in the group. Sir, VirtualBox isn't working, sir, to download Linux. See, VirtualBox will work. Try to either download it, try to first get to know whether your laptop supports 32-bit or 64-bit. Once you go for the configuration, then you can download. It will definitely work. Link didn't reach us. How it will not reach? In MacBook, sir. In MacBook, you can, Rahul, in MacBook, you can use VMware Fusion, Rahul, not VirtualBox. VirtualBox will not come in the Sir, next class, please explain how to install Kali Linux. Okay, I'll do, guys. I'll try to explain you how to install Kali Linux. I downloaded it, sir, when we start the practicals. Okay. Rahul, you can go for VMware Fusion. You will get lot of tutorials online and blogs. There you can basically see the whole process one by step, and you can download in your Mac. Okay, I'll just try to give you some kind of tutorials where you can watch and download, no problem. Sir, assignment last date. Sir, practical. I don't know what the problem. It's not opening, sir. It's showing aborted. Okay. Next class, please show to download Kali Linux, sir. How I execute man in the middle attack. Sorry to interrupt. The attendance link is crashing for me. Try to check your internet connection, Vishnu, once. In attendance and feedback for session 2 is showing. Can I continue with it? Because it been third session, right? Just a moment, guys. Just a moment. Guys, it is the same link, guys. You can download. When will be the next session? Guys, next session will be on Saturday, guys. So starting of session, you said you will share WhatsApp group link. And guys, if someone is in WhatsApp, try to please share the WhatsApp group link and also the Telegram group link in the chat box to everyone. Can you please explain about cloud security? Not now, right now, Bharat. Once we end the training in the last class, I will just give you brief how cloud security works and what are the domains. Thank you, sir, for teaching and solving our doubts. Thank you, Prem. Send link again, sir. Sir, can you explain tree topology? I will feedback. Tree topology. Just a moment. I'll show you tree topology again. Mesh bus ring tree. Yeah, I got tree topology. What is the doubt in tree topology? Someone asked about tree topology, guys. System one and system two, what will you use, sir? See, who is this? Yogesh. Yeah, Yogesh. Yogesh, actually, whenever you go for the central hub basically has only two connections. That is one system and another system. But whenever you go for a secondary hub, you have limitation of three systems can be connected, and again another hub. So central hub has only two particular systems connected. That is the limitation. Then if you want to connect more number of systems, you can go for a secondary hub, and again you can define system 3, system 4, and system 5. The properties of systems connected to secondary hub and the properties of connected to systems connected for central hub are same, exactly same. There is no difference. The only thing is central hub is connected to two systems, and if you want to increase the number, go for secondary hub. That is it. Done, guys. I guess we are good to go. Guys, if you are in Telegram link, that is more than enough, guys. Doesn't matter. If you're in Telegram link, that is more than enough. It is not important to be in a WhatsApp group or also in Telegram group. I guess Telegram group, everyone is there. It is okay. You can be in Telegram group, and please try to give the feedback, and so the feedback is only considered as your attendance. The link is shared again. Sir, can you explain about Nmap? Yes, we have a module, Umar, about Nmap. So in the next module is about operating systems. After operating systems, we will go with Nmap. I can't allow you to message in Telegram, guys. Everyone try to give your roll numbers in feedback without fail. If you give your correct roll number, then only you will get the attendance. Sir, if you have time, you can explain cloud security as well as phishing. Definitely, we will understand how phishing works, and how exactly what is cloud security. But it is in our curriculum, and we will go through the curriculum itself. Yeah, guys. Guys, see, one thing I want to tell, if you are not able to download Kali Linux, or if you're getting small errors, then it is not feasible for me in 2 hours class to resolve all the doubts, right? If you have Kali Linux error, if you have VirtualBox error, try to browse on YouTube, try to go for Google, you have lot of blogs, try to search for video tutorials. There you will get lot of videos from scratch, they will try to explain you, some 10 to 15 minutes. So we have lot of curriculum to cover, and I can basically explain you how to download Kali Linux. It is very small thing, okay? So it is like a small spoon feeding. So I can't spoon feed you, right? You need to learn on your own how to configure and how to do. If you after downloading, after everything, like if you're not getting internet in the virtual box in Kali Linux, if you're not able to access internet, you're not able to access few files, that I can tell. See this video and learn on your own. See, this particular person shared the video link. You can go to that video link, and you can, there are a lot of videos, guys. Try to utilize the free material which is present on the internet, and try to learn. Okay, that's it for today, guys. Thank you. That's it for today. Thank you, everyone. Everyone can leave the session once you have filled the feedback form.